Lesson 66, Algebra 2, Signs of Fractions and 30, 60, 90 triangles. So pretty much this is a little bit of theory. Every fraction has three signs to it. Okay, so if I have 3/4, there's three signs there. There's a plus sign, and a plus sign. If we were wanting this to be negative, we could have that. Okay, that's a negative 3/4. Because a negative, there's an odd number of negatives on the answer. Alright, so one of the things that's really important when you're trying to determine whether a fraction is positive or negative or what to do with all the signs is there will always be three signs. If there are an odd number of negatives, the answer is going to be negative. So, negative 3 over negative 4. These two are positive because a negative over a negative is a positive, and I'm left with a negative answer. If I've got one negative here, I get a negative answer. Okay? Other than that, the answer is going to be positive, or the fraction is going to be positive. So let's put some of that to use, and they're only giving us a couple of examples. So let's go ahead and do that. So they give us 1 over x minus 3, and then that's minus 7a over negative x plus 3. Okay, my a looks really nasty, so let's rewrite it there. So here's the key. I need to get common denominators. I have the same numbers. The problem is the signs on these numbers are different than the signs on that number. Alright, so the way this works is, like I said, there are three parts to this. We've got a plus here, a minus here, and a minus there. Three signs to this fraction. We can change any two of the three signs, and we do not change the value of the fraction. Okay, so we can change any two of the signs. In here it can get a little confusing if you're not really paying attention. Alright, let's look at this here. We've got a negative positive 7a over a positive negative x plus 3. Okay, notice what I did here. I'm not just looking at the negative here. This whole thing is a group. So remember when I showed you just a minute ago, we've got 3/4 and we have a sign in front of there, a sign in front of there, and a sign in front of there. This sign here is in front of everything that's in the denominator. So this positive sign covers the 4. This positive sign covers everything in the denominator. Okay, so the rule says I've got three signs here. I can change any two of these signs and keep everything the same. Well, I don't really care about changing the 7a. That's not giving me a problem. The problem is right here. The signs are messed up so that I don't have a common denominator. But if I could change this to a positive and that to a negative, then I would have a common denominator. So I can do that if I change this x here to a negative, and if I change this negative to a positive. There, I changed two of the three signs. And what do I get? 1 minus x minus 3, the first term, and let's go ahead and write that, plus 7a, we didn't do anything to the top, over, distribute this negative. A negative times a negative is a positive x. A negative times a plus 3 is a negative 3. Now I have common denominators. Now I can write it as 1 plus 7a over x minus 3. Okay, really confusing, isn't it? Alright, let's do another one. Let's do the second example here. And they only give us two examples. I wish they gave you a lot more, but we'll just keep practicing it. 4x plus 5, and that's over x minus 3. And this happens quite a bit. Having the same numbers on the bottom, just when the sign's goofy. So let's look at just this fraction right here. Alright, so that fraction can be written, let's put it in blue, as plus a plus that. Okay, so we are going to change the second fraction by changing two of the signs. We know we're going to change that one because these signs have to be different. But let's change this one, and we'll leave this plus sign alone. So we get 4x plus 5 over x minus 3, and we'll change this to we'll leave that as a positive, but we'll change that to a negative. And we'll change this one to a negative. And let's go ahead and distribute that negative. That negative distributed gives me a 2x plus 3. And this one gives me a negative 3 plus x, which I can actually switch around to an x minus 3. Okay? Now I can put my numerators together. And this is because this is a negative and a positive and a negative. I'll just put a minus there over x minus 3. So then that gives me 4x minus 2x is 2x. 5 plus 3 is 8 over x minus 3. Alright, so key thing is rewrite the second part of the fraction like this. Show me all three of the signs that are on here and change two of them. Obviously one of them you're going to have to change is the denominator so that the signs change so that we have the same denominator. But then it doesn't matter which of these two you change, but two of the three have to be changed. Alright, so that is the first part of this lesson. Let's jump to the second part, which is called a 30, 60, 90 triangle and a 45-degree triangle. And you will be using those a lot. So 30, 60, 90 and a 45. And every single triangle in the whole history of the universe, it's a 30, 60, 90, will look like this. Alright, so the book teaches it one way. I teach it completely different, surprise, surprise, but I teach it this way because eventually it will become very helpful to you. So that's a 30, that's a 60, and that's a 90. So the ratio will always be the same. So if, for example, I've got a big 30, 60, 90, and if this number is 3, notice when this number is 1, what's this one? 2. It's double. So when this number is 3, this number will be double. And notice what happens here. What number is in front of the square root of 3? A 1, right? So this side is always going to be the length of the shorter side times the square root of 3. So this length here will always be the shortest side times the square root of 3. Okay, so what I do then, instead of use this formula that the book does, I use one that's kind of similar. Let's go ahead and get rid of what I've got here. Let's go ahead and write the one they gave us, 1, 2, square root of 3. And let me tell you what I do. 30, 60, 90, but I say this length, and this length. Because then, if it says, all right, the shortest length, if they say, okay, the length of this bottom here is 4. Well, if I know this one is 2x, and I know this equals x, then I know automatically that this one is 8, and this side here is always going to be whatever x is times the square root of 3. So I use this, and that helps me a lot as far as solving this. Alright, so let's look at a 45-degree angle, and we'll get some more practice with that in a minute. But a 45-degree angle, do they even go into 45s? No, this lesson doesn't even go into 45s. It just sticks with 30, 60, 90. So, sorry for that. Let's jump to example 66.3. So they give me a triangle here. they give me? This is y, this is x, and this is 5. And they're asking me to find x and y. So, I know that according to my little triangle here, when we have an x, a 2x, and an x square root of 3. Alright, so what number are they giving me? They're giving me 5. What is 5 equal to? It's equal to 2x. So 2x equals 5, right? The length of the hypotenuse here will always be 2x. So that means x is actually 5 halves. So what did I find? I found that. So when 2x is equal to 5, x is 5 halves. So what is the length of this one? Well, whatever x is times the square root of 3. X is 5 halves. So this length is 5 halves square root of 3. So I just found the two sides that I was missing there. Okay? The book uses scale factors and all this other dumb stuff, but sorry, I guess I shouldn't say it's dumb stuff, but it seems kind of ridiculous. Let's look at practice problem C, because one example doesn't really seem to cut it. I'm going to put my triangle up there as x, 2x, and x square root of 3. Alright, so what do they give us? They give us a triangle. Looks like that. They tell me that's 7, that's B, and that's A. Alright, so this is the right triangle. So this number here, 7, is this side right here. So 7 equals x square root of 3. Okay? So how do I get rid of this square root of 3? Well, I can divide it. Okay? And remember, I can't have a square root of 3 in the denominator, so I have to multiply top and bottom by the square root of 3. And that gives me 7 square root of 3 over 3. So that's the length of, that is my x. That is, that is my x. That's this number right here. 7 square root of 3 over 3. Now I need to find this. Well, what do I know about the hypotenuse? The hypotenuse is double the short side. Well, I just found out the short side is that. So I'm going to double it. That equals 14 square root of 3 over 3. So that is the length of that. This is the length of that. So you keep practicing these, and you'll end up being fine with this for lesson 66. Looks like that was the only one. Oh, no, I guess 22 is just like what we just did. So anyway, you have one to do on your own. So that's it for lesson 66.